Hello everyone, this is Wafula Alan Samuel, math physics teacher, but tonight I will be teaching you mathematics, and the theme of today is integration. When we talk about integration, it simply means putting parts together. For example, as you know, God is a scientist. He made a human being by integration. He integrated different parts of the body to form one person. The head, the eyes, the nose, and the whole structure. So he formed one whole thing. So tonight, as I'm going to be taking you through this integration, this goes to the candidates, senior sixes, that are preparing for UNEB. So we have done more of some integration, and now tonight we are going to be proceeding from where we ended. So when we look at, for example, you are given a problem integrating from 0 to 4 root of 3 x over x power 4 plus 1 with respect to x. If this is our challenge, the problem, the examiner wants us to find how best can a student get the correct answer. We look at it that x power 4 plus 1 as our denominator, and the numerator is x. So we would ask ourselves, what best method can be used here? Because if you try to see, if it had been x power 4 minus 1, then we would apply partial fractions. Then, or if it had been x squared plus 1, then we would have integrated using tan substitution. But we realize that it is x power 4 plus 1. There's no coordination between the two. So the rest, what we do, we are going to change the variables. We integrate by change of variables. How? By saying let p equal to x squared. I let my p equals to x squared. Then after I've let that, I differentiate the p with respect to x. This gives us 2x. So we are going to make dx the subject. So implying that our dx gives us the p over 2x. So we have got the value of dx, we shall substitute in with 2p over 2x. But remember, we have limits from 0 to 4 root of 3. And these limits are in hand with x. So since we are changing our variable from x to p, then also it implies we are to change the limits from x to those of p. Most of the teachers, my colleagues, in other schools, for them they think that if we have limits, you can ignore them, then bring them at the end. That is very, very wrong. The mathematics should be correct if we also change the limits. So this is how we shall change the limits. We draw a simple table. This side we put x, then this side we put p. So we remember our p as a formula is x squared. So we are going to say if my x is 0, what becomes the value of p? When I square 0, I'll also get a 0. Then, if my x is 4 root of 3, and I square it, what do we get? Because you know when you square 4, you get 16. And when you square root of 3, you get 3. So 3 times 4, so times 16, you get 48. So the limits are no longer 0 to 4 root of 3, but they are now 0 to 4 to 48. So we rewrite our integral as 0 to 48. Remember, we still have here x. So now remember this is x to power 4. But we have just let our p to be x squared, implying that if we substitute in back, this will give us p squared, then plus 1. But remember our dx, we had already taken it as to be dp over 2x. So this becomes dp over 2x. So this x down here will cancel with this x. So you shall end up having a half integral from 0 to 48. 1 out of p squared plus 1 with respect to p. You remember I had told you that if here we had been given x squared plus 1, then we would directly use tan substitution. So at this level, we see it is now p squared plus 1, which automatically gives us our tan substitution. So how do we do? At this level, we just, if you have a mathematical eye, you just realize that this is arctan of p. But now, because we are dealing with people of different caliber, this is how we shall say let our p square equal to tan square of u. I'm now introducing in tan substitution. Thereafter, I apply the square root on both sides. Our p becomes a tan of u. Thereafter, I differentiate. I say dp du gives me sec square of u. I make dp the subject, so dp will be equal to sec square u du. Then after that, I come to substituting. This with what we have been given. But remember now, since we are also changing from p to u, it also implies that our variables are to be changed. So thereafter, I quote, I say this is my p, this is my u. So thereafter, I say if my p is 0 and 48, what becomes my u? But remember our u from here, I can be able to get the value of u by saying that u from here, that if we know that p is the tan of u, then this implies that u is the tan inverse of p. So thereafter, when I'm getting the value of u, I'll say p to get u is tan inverse of p. But our p is 0. So tan inverse of 0 will give us 0. But as we are doing this, our calculators must be in radians. Then we come to get the value of 48. So we can use the scientific calculator by saying that, arctan of 48 will give us 1.54996. Then after, we go back and integrate by saying it is now from 0 to 1.54996. This is 1 out of, remember our p square is tan square, then plus 1 with respect to the p, but our p, the p is equal to sec square with respect to u. So we know very well that sec square is the same as tan square plus 1. So these two will cancel. Remember we had our half. This is a half which is out. We shouldn't forget it. So when you integrate now this, we have got a half integral from 0 to 1.54996, then with respect to u. So when you integrate this, we shall get a half u. Limits are from 0 to 1.54996. So from here, we just substitute in the limits, and thereafter this gives you a half into 1.54996 minus a 0. And thereafter our answer will be equals to which gives us 0.77498. And that becomes the integral of this variable. So sometimes we can also be given integrals without limits. So when they don't have limits, we put a constant of integration. Thank you.